So we have this linear equation to solve, and I will be following my time-honored bad habit and show you two different solutions. The first one has to do with the fact that the constants are the same, it's just the numbers are fractions. If you know how to solve this equation, you do know how to solve this equation, because it's the same thing. A number times x minus a number equals a number times x minus a number. So we're going to perform the exact same steps that we would do in case of an equation like this, only every step will take a little more work because we're dealing with fractions. That's method number one. So let's see that. First, we're going to distribute 1 over 10. And notice at this point, and keep it at the back of our mind, that 14 over 10 can be simplified to 7 over 5. That might make our life easier, or we need a common denominator of 10. Either way, just keep an eye on it. So first, we're going to work on the fact that both sides contain x. Clearly, this is much smaller. This is 0.1, this is 2.5, right? So we're going to subtract 1 over 10x from both sides. On the left-hand side, we're going to be left with negative 14 over 10 alone. And on the right-hand side, for the coefficient of x, we're going to have to perform the subtraction 5 over 2 minus 1 over 10. So the common denominator is 10. And then 2 to 10 is 5 times, so we have to multiply the top by 5, that's 25. So we have 24 over 10, or 12 over 5. Okay, so now it's a two-step equation with yucky coefficients. So next up, we want x on one side done, but alone, so we're going to add 3 over 5 to both sides. So then, on the right-hand side, we're going to have 12 over 5x alone, and on the right-hand side, we have to perform the addition negative 14 over 10 plus 3 over 5. I think now it's a good time to recognize that this can be simplified as negative 7 over 5. See, they can meet downstairs in 5, we don't have to go up to 10. So then negative 7 plus 3 is negative 4, so we have negative 4 over 5. And now we're going to divide both sides by the number multiplying x to get rid of it. So we're going to divide both sides by 12 over 5. If we do so, the right-hand side will have x alone. And on the left-hand side, we're going to have negative 4 over 5. To divide is to multiply by the reciprocal. So we're going to say times, and we're going to flip this number, so it's 5 over 12. Lovely cancellations, this is very clear. And then we're left with negative 4 over 12, they're both divisible by 4, so if we get rid of that, we get x is negative 1/3. Before we check, let me show you this other technique. So the second method is based on not only comparing our equation to something like that, but actually turning it into something like this. And that can be done if the coefficients are fractions, because every fraction can be turned into an integer with a suitable multiplication. We will have to find a common denominator between all expressions within the equation and then just multiply by it. So I'm going to show you, again, two ways. Now, clearly 10 is a good thing to multiply by. So we have two options. We can either bring stuff to the common denominator and then wipe it out, or just wipe it out. But you still have to know what we're looking for. So we're going to multiply both sides by 10. When we're multiplying the left-hand side by 10, all we're going to do is make this disappear. So after a multiplication by 10, we're going to get x minus 14 alone on the left-hand side. Now what happens when we multiply? Well, we're going to have the distributive law, so we're going to have to multiply both pieces by 10. So 5 over 2 times 10, the 10 will knock out the 2, but because it's more than the 2, we're going to be left with a 5. So 5 over 2x will become 25x. Right? We're hitting it with the 10, but once 2 disappears, the 10 is there is only 5 left from the 10. Minus, and then 3 over 5 minus 3 over 5 times 10. Again, we cancel out the 5, and we're left with the 2, so that's negative 6. Eventually, you're just going to go like this. I want to multiply by 10, so in this case, this disappears. Here, 10 will disappear to 2. I have 5 left. 5 times 5 is 25. Here, We'll knock out the 5. There is still 2 left, so we multiply that. And now it's a very easy equation with integer coefficients. We're going to subtract x. So that's negative 14 equals 24x minus 6. Now we're going to add the 6. So that's minus 8 equals 24x. And now when we divide by 24, we get minus 8 over 24 or minus 1 over 3. So we got the same answer. Always good news. So eventually this is the step you're going to make. If you feel like this is too much of a jump, then do this. So we multiply, let's first bring stuff to the common denominator. So this is the same as x minus 14 divided by 10, right? There is just a multiplier of 1 upstairs. This one, let's bring it to the denominator of 10. 2 to 10, that's a 5. So 2 to 10, we multiply the denominator by 5. We must do that to the numerator. And same thing here, 5 to 10, that was twice. 3 times 2 is 6. And now we're going to multiply by 10 and thereby wiping out the entire denominator. See, we get the same equation? So first, if things were too fast, first have this line, but eventually you're just going to go for this one. Alright, so let's check. So we think that x equals negative 1 over 3. So then the left-hand side is 1 over 10 times negative 1 over 3 minus 14. I'm going to write 14 over 1 because I'm kind of sensing a common denominator situation. To bring this to the common denominator, 3 is a good common denominator, so we're going to multiply upstairs and downstairs by 3. And so we get 1 over 10 times negative 1 minus 42 is that 1 over 10 times negative 43 over 3. It's negative 43 over 30. Alright, so let's see the right-hand side. So the right-hand side would be 5 over 2 times negative 1 over 3 minus 3/5. So the multiplication would be negative 5 over 6 minus 3 over 5. See, we're going to be forced to the same denominator as the other side. That's sort of encouraging. So the common denominator is 30. 6 to 30, that was 5. 5 times 5 is 25. 5 to 30, that was 6. 6 times 3 is 18. We did get the same answer. So when x is negative 1 over 3, then both sides are a fairly unpleasant fraction. Nonetheless, they are equal to each other, so our answer is correct. Thank you for watching.